In this video, we are going to look at more examples of doing U substitutions. Here, we are looking to integrate the cube root of 3 minus 4x squared times negative 8x dx. So here, the first thing I would ask myself is, can I integrate that directly? Can I integrate that using the antiderivative rules that I have previously learned? Because we have a product of functions and it's not easy to go ahead and multiply those out, I'm going to try to look for another method to solve that. So here I notice that the cube root of 3 minus 4x squared, that is a composite function. The inside 3 minus 4x squared, I could call that u. So let's say u is 3 minus 4x squared. If I were to make that substitution, what would du be? Du would be negative 8x dx, right? Or du dx is negative 8x, and then you can move that dx to the other side. And so all of this stuff right here is just du. So this problem I can rewrite as an integral of the cube root of u du, which is the integral of u to the 1/3 du. If I started with this as a problem, could we solve that? Sure, we have integral rules that allow us to handle that. We're going to add 1 to the power, divide by the new power. So we have u to the 4/3. We have a 3/4. So dividing by 4/3 is the same as multiplying by its reciprocal, plus c. We're almost done with this problem. We need to change back from u's back to the original variable. So what is u? Well, u is 3 minus 4x squared. So 3 minus 4x squared to the 4/3 plus c. And that is our antiderivative using u substitution. Perfect. Let's look at another example where we're going to look at a definite integral. So here we have a definite integral. We have the integral from 1 to 3 of x cubed over 1 plus x to the 4th squared dx. So we could think of this as an integral from 1 to 3 of x cubed times 1 plus x to the 4th to the negative 2 dx. I can't multiply that out. We can't just distribute that x cubed in because of this power here. So what can we do with that? Well, again, we can look to see, can we do u substitution? And so here I would consider this 1 plus x to the 4th is that inside function. So then our derivative is 4x cubed dx. Well, we have an x cubed dx, but we are missing that 4 out in front. So what can we do? Well, the way I like to think about it is this. We could write it as one plus x to the 4th to the negative 2. I'm just going to multiply by a 4 on the inside. But if I multiply by a 4, that changes the problem. So on the outside, I need to divide by a 4. So that's the way I think about it. Other people think about it a little bit differently. Other people might solve this over here for x cubed dx, and they can say x cubed dx is 1/4 du. You will end in the same spot, and so however you want to think about that is fine. So now we are going to make the substitution. So we have 1/4 the integral of u to the negative 2 du. Right, so remember, all of this is du. This is just our u. Now you'll notice I haven't written my limits of integration yet. Why have I not yet done that? Well, the reason I haven't done that yet is because that 1 and 3 those are x values. If I wrote a 1 and a 3 here, someone that read this problem would understand those to be u values. When they look at this line, if I had a 1 and 3 here, they would understand those to be u values. So there's a couple different ways we can do this. I'm going to do this problem a second time, but one way we can do this is we can change those limits of integration. We can change them from x values to u values. So over here to the side, if x is equal to 1, what is u going to be equal to? Well, u is 1 plus x to the fourth, so it's 1 plus 1 to the fourth. Our u value is 2. If x is 3, u is 1 plus 3 to the fourth, 1 plus x to the fourth. And so then it would be 82. And so these limits of integration we can change to 2 and 82. And then we'll take our antiderivative. So we can integrate this. U to the negative 2, we'll add 1 to the power. U to the negative first, divide by the new power. So dividing by negative 1. We're going to evaluate that from 2 to 82. So we have negative 1 over 4 times 82 minus negative 1 over 4 times 2. And if you solve that, you'll get 10 over 82 or 5 over 41. So that's one way we can do that. Notice when we change those limits of integration to u values, we never had to return to our x values, right? So we didn't go back to the x values. So we're going to go through this problem again, only instead of changing things here, we're going to just return back to our x values. Right? So a lot of this initial work is going to look the same. So we have an integral from 1 to 3 of 1 plus x to the fourth to the negative 2 times x cubed dx. We're going to say u is equal to the 1 plus x to the fourth. So du is 4x cubed dx. We have our x cubed dx, so we could say x cubed dx. So I'll do this the other way that I mentioned. So x cubed dx is 1/4 du, so we could replace this with 1/4 du. And so now we have an integral of u to the negative 2 times 1/4 du. Those limits, that 1 and 3, those are x values. So I'm going to just put a place saver here. So I'm just going to put stars there to say there are values there. I don't know what those values are. Now some people might not like that. For me, I'm okay with that. You might say we're going to integrate it from x equals 1 to x equals 3. You could do that instead. You'll have to talk to whoever might be looking at your stuff to decide what is appropriate notation here. Here, there are definite limits. I just don't know what those are in terms of u. I'm not going to find those. So we have that 1/4. You can bring that out in front. U, when we find that antiderivative, we add 1 to the power and divide by the new power. And we are going to evaluate that thing from this lower limit to this upper limit. Again, we don't know what those values are in terms of u. We didn't take the time in this problem to find those. And so instead, what we will do is we will go back to x values. So this value u, it is 1 plus x to the fourth. So this is times 1 over 1 plus x to the fourth. And we are going to, now that we've changed back to x values, now we can use these limits of 1 and 3. So we have negative 1/4 times 1 over 1 plus 3 to the fourth minus negative 1/4 times 1 over 1 plus 1 to the 4th. And if we do that, we should get exactly the same thing that we got on our previous page. So we'll get negative 1/4 times 1 over 82 plus 1/4 times 1/2. And if you solve that, you'll get 5 over 41. So here, if we don't change these limits to u values, we need to return to the values of x so we can plug them in. Or on the previous page, we changed those limits from x values to u values. If we make that change, then we didn't have to return to that value of x. Perfect. Come back for our next video and we will look at more examples. We will see you there.